Hi everyone, this is Mark Schuyler. I'm here today to share with you missing formula number 2 for the math section of the SAT. Even though the SAT provides us with a fairly nice reference information page at the beginning of each math section, they do not include all the formulas that we need. Here is missing formula number 2. It's the formula we use to figure out how many degrees are inside a polygon. Who knows what polygon you might be confronted with on test day? It might be a quadrilateral, a pentagon, a hexagon, an octagon, or a decagon. You don't have to walk around having memorized how many degrees are in each of these shapes. Instead, the only thing that you should have committed to memory is a very, very easy formula, the quantity n minus 2 times 180 degrees, where the variable n stands for the number of sides. So if you have a hexagon, you can plug in the number of 6, the known number of sides in all hexagons, subtract 2, which yields the answer 4, and multiply 180 degrees times 4. And you get 720 degrees are inside of that hexagon. You can answer this question by simply solving for x by subtracting the 120 degrees of each of the 6 angles in the hexagon from 180 degrees. Where did I get the 120 degrees? Well, I got it by knowing that I would have to divide the total number of degrees, 720, by 6. Got my 120. I know that that angle is supplementary with x, has to add up to 180, and voila, we have our value. That problem, by the way, is rated level 3, meaning it's medium difficulty. 50% of the kids in America cannot answer that question correctly, no doubt because they have forgotten or never learned the formula for figuring out how many degrees are in a polygon. I want to make one quick little plea here. There's another interesting way to be able to figure out how many degrees are inside of a polygon, and my plea to you is you should know this as well. Instead of using the formula, you could put your pencil down on one of the vertices, one of the vertices, and very carefully draw a line from that vertex to every other vertex in the polygon. And if you do that, and this is important, you always start from the original vertex when you're drawing lines out to each of the vertices. You'll notice that there are always 2 fewer triangles inside of the shape than the number of sides that the shape has. In other words, if somebody said to me, "Hey Mark, how many triangles would you be able to draw inside of an octagon?" I'd say 6. How many triangles are inside of a decagon? Well, a decagon's a 10-sided shape, so I'd be able to draw 8 triangles inside. And you see, that's why the formula works. Because the formula, again, says the number of sides minus 2 times 180. Well, that 180 is because every triangle is made up of 180 degrees. So the backup method is pretty important. I've actually seen SAT problems that pretty much come right out and ask, if you have a 12-sided shape, how many triangles would you be able to draw if you started from a vertex and you drew straight lines to all the other vertices? Well, you don't need to spend a minute or two drawing a picture for yourself. This is something that you should just know off the top of your head, that a 12-sided shape known as a dodecagon will have 10 triangles inside. Thank you for listening. It's great to share with you another one of the missing formulas from the SAT.